last but not least, Mr. Praveen Thirumurugan is going to speak on microservice orchestration with GCP serverless offerings.
He is presently employed by Plum as a software engineer. He made significant open source contributions early in his career and has served as the GDG Cloud community's lead for a number of years. Please welcome with a huge round of applause.
Cool. Hope I'm audible. Hey, so let's start. So let's, not take a lot of your time. It's already 6:30, I think. This is the last session. So how was the day today? Are you all excited? Did you learn new things? Yes, great. So hope you will come for further events also. So let's start without any further ado. So before we start, do you know this term, monoliths? How many of you know this? Cool. So today's talk is going to be about the differentiation about monoliths and microservices, and we will see a short demo on how we can actually orchestrate two microservices in GCP. Okay, all good? Cool. So see, this is the old architecture that was used by many of the organizations until recently. So if you see here, there will be one big monolith deployment. Even it is being used by certain organizations now. So there is no, it is not that it is wrong to use monoliths and it is only right to use microservices. Each architecture has its own nuances, advantages and disadvantages. And based on your needs, you would be choosing the architecture which would suit the team better, the company better, and the customers better. So if you see this monolith deployment, this is a traditional application. It has a lot of services, authentication service, order service, notification service, etc. And their company also has two applications, which is customer facing. One is merchant application and one is the end users who actually consume that application. And they have a common database as well. So you got that architecture, right? That is monoliths. And now talking about how it evolved from monoliths to microservices. If you see earlier, there was only one server which was self-hosted. Maybe that is on-premise, or even the founder's home used to have a machine and they used to host the application as well. That was the earlier stage. And then cloud providers came into existence. They offered VMs so that people can rent virtual machines on cloud, deploy their applications there. So that's how it started evolving. And if you see certain advantages of monoliths, if you see every code is in one place, right? And everything is in common language. And end-to-end testing is very much easier with such architecture. And it is easy to understand if you know the code, and also the data would be consistent. But why does this not work actually? Any guesses? Quick guesses. Yes, that's right. So there are a lot of downsides as well. Certainly there are more advantages which I did not include, but these are certain kind of disadvantages it could bring along with your architecture, right? You need to redeploy, even if you want to change a small thing in the authentication service, everything needs to be redeployed if not architected properly. And you would be adding unnecessary libraries which is not used at all in certain applications. And yeah, a lot of problems as well, right? So for today's talk, let's take one example. Let's think of Amazon or Flipkart. This is the regular application that you use, right, on everyday basis. So if you are going to place an order in Amazon or Flipkart, so these are the sequence of steps you think that would happen, right? So if you see here, you need to update the inventory. You need to notify the merchant, the customer via email, SMS, WhatsApp, etc. And there could be offers involved with that order, so you need to process those offers as well. And and other important tasks as well, right? So what do you think can be done differently here? By looking at this slide, actually. So if you see here, the steps highlighted in blue, right? It need not be processed immediately when the user is placing an order, right? So imagine if you're going to do all these 8 steps, it's going to take a lot of time for the user, for the response, right? So say you have completed the payment and you're clicking on place order. What happens if the response takes like 20 seconds? It's not good, right? The user would think that the application is very slow. And the only step that you need to do is need to update the inventory in DB so that it's not available for another user. The stock gets updated, and everything else can be event driven. So that's the beauty of microservices. You get it right? It's simple. So earlier we had a very big monolith application. Now we are going to breaking it into smaller chunks. So this was the code earlier, and what we are going to do is we are going to transform it into like this. And what's the beauty is, earlier on the monolith deployment, you were writing with a common runtime, say Java or C++ or C#, whatever. Now you can bring in more distributed teams into your company. So one team can be proficient in Java, one team can be proficient in JavaScript. It's up to you, right? So monoliths, monoliths doesn't bring that exclusivity for you. But now you can actually take advantages of those, and not only the runtime, but you could also deploy it on various other services. For example, if I think that I need to deploy authentication services in Cloud Run, and my orders, warehouse services somewhere else, or whatever it is totally possible. So this brings us to how we can orchestrate multiple microservices on the GCP terms we'll be discussing today. So one way is the basic HTTP method, right? So this is very universal. Wherever you deploy your application can talk to each other using the HTTP endpoints. So one application would have an endpoint and another application would have an endpoint. You can transfer the messages or call another service using HTTP API calls or REST API calls, whatever it is. The next thing is Firestore, there are multiple database triggers available in GCP. Say your authentication services using Firestore database, and say that there is a user registration. So you create a document in Firestore, and what Firestore does automatically for you is it natively creates a trigger, and a cloud function can be invoked based on that. And that cloud function could process further steps like providing referral coupons to the referred user, or creating other database entries for that user, which are not immediately required. So this is one beauty of Firestore. And the next thing is PubSub, right? So PubSub might be very complicated, or it might not be even necessary for basic applications when you start, but this is an amazing tool. So it can scale in terms of millions of events per second, and it would not degrade at all. So this is one service which you can back up for scalability. And as multiple speakers talked before, right, it can be used for IoT, a lot of event-driven services. And now if you see our microservice, we have splitted everything now. So the initial microservice which process the orders, it just updates the inventory, puts a message on the PubSub queue saying that a new order has been received, and all the three microservices would be pulling from that event, or a push event would be happening to these microservices endpoints, and it would execute on its own leisure. And now the API speeds would be very fast. You get the concept, right? Cool. Let me show you a small demo actually. Okay, so I have an application here which has a form called as, with the field's name and email. So this is a very simple explanation to the problem, the microservices problem. So what this is going to do is it's going to get the name and email, and it is going to send an email saying that we have received a request. And also it's going to update on DB saying that this request was got at this time. So if you see the API, this is a very, very small example. It doesn't even need microservices, but just to give you a picture of how it works. Can you see the code? I think no, right? Okay, no issues. We are running out of time actually. So this is a very simple API which just publishes an event to PubSub. That's it. So what it's going to do is it's going to publish the name, email, and Firestore event ID for this. For the form fields. And if you see in cloud, so this is a topic. So this topic is called as send an email, and in turn it has two subscriptions. One is save to DB and send an email. So these two are separate microservices which executes its own code. So one would be saving the data to Firestore and one would be sending an email. That's it. So now if you see, the API was very fast, right? So it didn't take much time for the response of email, right? So whatever email service I'm using, I need not await till the response is obtained from the email provider, and I need not wait till the database entry is also made. If you see here, I've got the email now, and also on the database, there is an entry here. So this is how it works. Any questions, I'd be happy to take after this. Thank you so much.
Thank you so much, sir, for your guidance and such an amazing session. Thank you.
Now I'd like to invite Nyanada Mahajan to please felicitate our speaker.